Assalamualaikum and a very good day everyone. So today we are going to learn another methods of analysis. There are two type of method here that we can learn in this subject, which are first is the the nodal analysis, and the second one is loop analysis. So this is the first analysis, a nodal analysis, which is it is used to solve the circuit by calculating the voltages at nodes, the node voltages, using Kirchhoff current law. So we learned about this KCL before, right? So this nodal analysis will utilize this KCL in order for us to analyze the circuit. Alright, let's consider this circuit. Let's consider this circuit. There are three branches. Okay, first, how to do the nodal analysis? There are steps that we need to follow. First is we need to identify the nodes. Okay, from here, how many nodes that you can identify? There are 1, 2, 3, and 4. Here, 4. Okay, as I said, node is being defined by a junction that have elements in it. So basically here there is node here, okay, here node, and there is element here, so there will be another node here. There is element here, there will be another node here. There is element here, so here should be another node, but this is no element, so this is the same node. So basically all these are one node. Okay, understand? Next, we need to select the reference ground, the reference node. Which one is the ground? In our circuit, it always have ground actually. In any circuit, if they didn't put like this, or they didn't put anything symbol like this, you can simply choose the bottom one as the reference ground, as the reference node, the ground. So the ground, the voltage will be 0. Okay, ground means the voltage is 0. Alright, so we know this is V naught, and the third step is we need to label the node with the voltage number. Okay, for example, label this as V1, V2, V3, and this is V0 because this is reference node. Okay, understand? Okay, maybe someone say, oh, I don't like V1, I want X1. It's okay, it's depend on you. The labeling is all depend on us. Okay, usually we use V1, V2, V3, and the reference node is the VO, V naught. Next, we can identify if there is any non-voltage. The voltage that we have already know the voltage, we doesn't need to calculate it. So for example, this, okay, this node. We already know this node is equal to 9 volt because there is a voltage source here. Okay, voltage source without any other elements. Remember that. If there is a resistor here, this node will not become 9. Okay, there will be something 9 plus this voltage drop if there is a resistor here, but this now there is no resistor, so the voltage here is equal to 9, right? And this also we already know this is V naught is equal to 0 volt. Okay, we know these two node, this is 9 volt, this is 0 volt. How about this? How about this? Do we know this? We don't know. We don't know any voltages here yet. Okay, this is what we need to calculate. We need to find the value of V2 and V3. Next, so we already know V1 is equal to 9, V0 is equal to 0. So we need to apply KCL on the unknown voltage node. Which is the unknown voltage node? This V2 and V3. So remember that in nodal analysis, there are two laws that you need to follow. First is the KCL. Second is the Ohm's law. Okay, what is KCL? KCL means the current in is equal to the current out. Okay, and we need to consider also the Ohm's law, which is V equal to IR. But for nodal analysis, we always want to find the I here because we are using KCL. KCL is currents, right? So we want to use I equal to V divided by R. Okay, so we need to apply the KCL on the node 2 first, this node first. So we know this is current in, okay? Okay, before that, we need to remember also, okay, if we put this direction, this current direction, okay, this from here to here, like this, so the current is flowing, look carefully at this, the current is flowing from V1 to V2. So V1 has higher potential than V2. Okay? We are assuming this. Okay? This is all assumption. Okay? Because we assume that this is the direction. So we assume that this V1 has higher potential than V2. Alright. So the Ohm's law equation must be V1 minus V2 divided by 1000. Right? If you guys want the current to be like this direction, different. So what is the equation? V2 minus V1 divided by 1000. Okay? The answer will be the same. Believe me, the answer will be the same. It's all depend on us. Okay? So we already know that. Okay. So we know this I1. Then we assume the current out from B2 here. This is I3. And another one, I assume that current will be in here. I2 here. Can we assume like this? Yes, we can, but the equation will be following the direction of the current, alright? So in node V2 here, in node 2, this is how you write, okay, in your answer script. Node 2 here, so I1, using KCL, I1 plus I2 equal to I3, like this. I1 plus I2 equal to I3. Okay, so V1, so the equation will be, because the direction of the current like this, right? So the V1 minus V2 divided by 1000. Okay, this is I1. How about I2? I2's direction is like this. Okay, so V0 minus V1 divided by 3000. Okay, and the direction of the current like this. So V2 minus V3 divided by 2000. Right? And then we can also put in the value here. V1 is 9, right? We already know that. This is 9. How about this? Okay, this is wrong. This is not V1. This is V2 actually. Sorry, okay? Sorry. This is V0 V naught minus V2. This is V2 actually. This is V2. Okay? This. The equation in I2. V naught minus V2. So you know this 0. Do we know V2? Do you know V3? We don't know. So after you put all the numbers here, you can simplify it and it will become this equation. Alright? Don't tell me that you don't know how to simplify it, because this is all mathematics, basic mathematics. 1000, 3000 below, we need to make the below, the bottom one to be gone first. You multiply with 6000, maybe 6000, then you simplify, you will have this. Alright, all of you need to do this, okay? Need to simplify this, and you must get this equation. So you need to comment below if you're able to simplify it or not. Alright? Because if you're unable to simplify it, it will be trouble. You will have a big problem to do the analysis. Alright? Then, next, we want to apply another KCL in this node V3. Okay, node 3. This is node 3, node V3. The current here is in, and this is the current. Is this current out? No. This is the same current flowing through. Alright? So, in this current, V2 minus V3 divide by 2000. Alright? This resistor. And then this one, V3 minus V0 divide by 2000 also. Some students might ask, Doctor, can I just V2 directly minus V0 and then divide by 4000? Because this is series, the current is the same. Okay, remember that in nodal analysis, we want to find the voltage, not the current actually. We want to find the voltage. If you directly minus V0, you are unable to find the V3 here because the V3 terms is already gone. Okay, so you must do V2 minus V3 divided by 2000, V3 minus V0 divided by 2000. Okay, and then you add and you insert the numbers here, V0 equal to 0. And you simplify it again and you get this equation. Also, you need to do this. You must do this. You must simplify this until you get this equation. Also, you need to comment below that you able or not. If you really unable to do it, please comment so, because if you guys all say okay, I can, you just copy and paste your other friends answer. So I will not repeat this if we meet again. I will not explain it again. I will not help you because I don't know that you need help. Alright? Okay, so we already have that two equations. This first equation and the second equation. So we need to solve it. This is a simultaneous equation. This is a simultaneous equation where you can rearrange this and then you can use a substitution. You substitute equation 2 into equation 1 and you get this value. Okay? And then you substitute again the V3 value into equation number 2 here, and then you get this value. This value. This is the answer, V3 and V2. Okay. Maybe some of you want to use elimination method, also can, whatever you want to use, as long as you get these two values. Or you can use your calculator. Nowadays, the calculator is very advanced now. Before that, during my year, I'm using only substitution and elimination. We need to calculate it by ourselves. But now, all of you can use your calculator. Okay, we have these two equations. Remember, we have these two equations. We are using these two equations, not this, okay? We are using this and this. Why? Because we want the term. This is the first term, this is the second term, and this is the third term. Same as this is first, this is second, and this is third. Okay, if you are using a model of calculator the same with me, 570, just ignore this ring because my calculator is very old. Okay, so if you are using the same model as me, you can follow this step. If you are using different model, maybe some of the model is almost the same, but if you are using a very different, very advanced, like the calculator that can produce graph, I think that is very advanced. So you need to ask ChatGPT or just Google, or ask how to use calculator model to solve equation. Ask like that in the ChatGPT if you are using different model. But if you are using the same model as me, 570, you can follow this. Firstly, you need to press this mode. Change the mode of your calculator into equation EQN here, EQN, number 5. So press number 5, and then it will display like this. So this now I said there are 3 terms, right? 1, 2, 3. So you look at here. Look at here. This is 1, this is 2, this is 3. Same, right? Same. How about if you have 3? So if you have 4 terms, so you need to choose number 2, which is 1, 2, 1, 2, 3, 4. Okay? Okay. So after you press number 1, it will, okay, choose the similar number of them. It will show this display. Okay, it will ask you what is the value of term number 1, term number 2, and term number 3. Enter the value like this. This is the first term, so 11. Just enter 11 here. Press equal, this symbol equal, and then it will ask you again what is the value of b here, number 1. So press -3. Okay, -3 here, and then how about this? This is 54. Then it will ask you the second row. This is 1. This is -2. This is number 3 is 0. And then press equal. Every time you press the number, press equal. And then it will give you directly the answer without even using the whatever this now the simultaneous equation, the substitution, the elimination, whatever it is. You don't have to do that anymore. You just press your calculator and will give you directly this value. Also acceptable in the exam. Okay, just use the calculator, easier for you. So you get this value, okay, and then this value, same, right? Okay, next. So if you understand what I'm saying, you need to do some example. So given this circuit, you calculate the node voltages. If they ask you the node voltages, it means they want you to calculate the voltage at nodes. So first you need to label the nodes. What is the node? This is 1, 2, 3. Okay, 1, 2, 3. This is the reference node, okay, which is V equal to 0. So actually they want to ask you what is the node voltages here and here. What is V1 and V2? Okay. The second one, do you have any non-voltages? Not voltages? Yes, you have this only. V naught equal to V0, equal to 0 voltage. And then you need to determine the current direction. Okay, look at here very, very carefully. There is the current source here. So the current source, the current direction here, at these particular branch already being set. Okay, so the current must be go into the node 1. How about this? This also the same. The current must be into the node 2. Okay, and then the rest of the branches, so you need to set by yourself whether you want to be like this or you want to be like this. Depends on you. You set it by yourself. Okay, but don't put like all in entering lah. But put some, okay, if you put this enter, put this as leaving lah. Okay, leaving. Okay, put this leaving. Don't put all enter. Okay, just put one branch is leaving, one branch is entering, like that also can. Okay, then after you set your current direction, you need to provide the equation for the unknown voltage, unknown node. So what is the equation here? So if you are setting the current like this is like this. So you need to do the equation here. So V0 minus V1 divided by 2 plus, okay, because both of these are entering 5. This is directly 5. Why? Because, okay, look, this is, for example, this is, oops, sorry. Okay, so for example, this is I1. Okay, this is I1. You said this is I1. This is I2. You said it. And this is I3. Okay. So what is your KCL equation? I1 plus I2 plus I3 equal to I3 because I3 is leaving. Okay, so what is I1? I1 is here. So I1 is V0 minus V1 divided by 2 plus I2. What is I2 here? I2 is 5. It's already being given to you. I2 is 5. So you just do plus 5. Okay? You don't need to like V2 minus V1. There's no resistor here. Okay? The current is already being given. So just use 5. Equal to I3. What is I3 here? So V1 minus V2 divided by 4. Then you have the equation. Simplify the equation until you get the terms, okay, correctly. Also the same like V2 here, not number 2. So what is the current here? So you already set here as this direction, so it must be this direction. So both are entering, so the next is leaving. So what is the value? But the current here? 10. 10 plus V1 minus V2 divided by 4 is equal to V2 minus V0 divided by 6. And then you simplify the equation until you get the terms also the same as the term equation number 1. Okay, remember one more thing that I want to highlight here. If you already set the direction of the current, this direction, for this node, don't ever change the direction at node number 2. You already put like this, here also like this. Don't ever put the direction in a different direction. Okay? It will give you a wrong answer. Then after you get the two equations, then you need to solve the equation and provide me the answer in the comment section below. Okay? Also, if you really unable to calculate it, just say you unable to calculate. Doctor, I cannot solve it. So I know that you cannot do it. Then next week I will go to you and help you. If you just copy the answer, I will not know that you really understand what I'm saying. Oh, I cannot help you. Okay? please let me help you. So you need to do it by yourself, okay? Do these equations and provide me the answer. And next, there are two circuits here, so the same thing also. Find the voltages across 2 ohm and 7 ohm. So if they ask you like this, it means that they want the node voltages, which is the node number 1 here and the node number 2 here. Okay, so first you need to label the nodes. Again, this is nodes, and okay, label the nodes. So this is 1, 2, and there is another node here, which is the reference node. Okay, so like this, if there is no figure, right, there is no label here, no symbol like this, so you just simply put at the bottom, this is the ground. You label it by yourself. Okay, so this is V node. Okay, so this is V1 and this is V2. Do you know any node voltages here? There is any node known voltages? No, right? There is no. So both we need to find here. So determine the current direction. Also the same. So this is like this. So this is like this. So what are you going to do? How about the rest? Use label it by yourself. Okay. Try to label it by yourself. And then provide me the equation for the node voltages. Okay. For node number 1 and also node number 2. Right? Take out your tablet or wherever you have the paper or the pen, the pencil, you do it. Okay, and then solve the equations, press your calculator and provide me the answer. Right. Okay, thank you. Okay, not thank you yet. We need to do the I need to let you know the second analysis. Before this, we have learned about the nodal analysis. Now we want to go to loop analysis. Loop. Okay, loop. Okay, what is the loop analysis? Loop analysis is used to solve the current. Actually, they want to find the currents in the loop using KVL. Just now, nodal analysis are using KCL. Now, the loop analysis, we are using KVL. Okay, so consider this circuit. So firstly, the step is, firstly we need to identify the loops. Okay, how many loops are here? Can you guess? There are 3 loops, 1, 2 and 3. And then when you do the looping, I mean you put here 1, this is 1, right? 1, this is 2, this is 3. Okay, we need to label it also. Like before the nodal analysis, you label the node, right? V1, V2 and V0. This is also the same because we want to solve the currents, right? We want to find the currents, so we label it as I1, I2 and I3. Okay, next we already know the looping. Now we want to find the currents. Okay, we want to find the current. First we need to apply the KVL to the loop. Okay, we consider this loop first. Loop number 1 here. Loop number 1. We close the others looping first. Okay, we focus on this loop. Alright, so in this loop, this particular loop, the current of I1 is flowing like this. Okay, we set the direction also. We set this direction. We set the direction, the current of like this. Current jalan-jalan and here until end. Okay, one loop. But remember, look at here carefully. Look at this diagram carefully. In this particular resistor, the current flowing through the resistor is not only I1. There are I2 here. Okay? They are I2 here. Look, right? So at these branches, there are two currents flowing, I1 and I2. Also the same as this R1. The current flowing through this R1 is I1 and I3. Okay? So by applying the KVL, so this is the current flowing, right? Remember also, the current go to negative terminal. What is the voltage? Will be? Yes, negative. Okay, negative. Okay, the current coming to the negative terminal, it will be negative V1. And then here, the resistor. Resistor, if there is no any, the passive elements, resistor, inductor, capacitor, if there is no positive or negative being indicated here, we always put like this. Okay, follow the current direction. Okay, so the current coming in here is to the positive terminal. So what is the voltage? Positive or negative? Yes, positive. Okay, positive. Okay, so plus I1 multiply with R1. Okay, here, this is the voltage drop. And another one, current coming through the positive terminal of R3. So plus I1 R3. Okay, and as I said just now, in this particular R3, there are two currents flowing through it. I1 and the reverse direction. I1 is like this. So this is the reverse direction of I2. So reverse direction. Look, I2 is going to the negative terminal of R3. So the I2 will be negative. Negative I2 plus R3. Okay? Are you following me now? Okay. Now, how about the R1? Also the same. There are two currents flowing in. So R1 is, this is, the I3 is a different direction. So it go through the negative terminal here. So it will be negative I3 multiply with R1 equal to 0. This is a KVL rule. All the summation is equal to 0. Okay? You guys get it? Okay, this is very, very important for you to understand. Okay? And then, now, you arrange it. Arrange the terms. So you get this. Put all the I1 here at the first one because number one, right? So the first one, put it the left, the most left. So I1 plus R1 plus I1 multiply with R3. And then put the second term, negative I2. And then put the third term, negative I3. And the fourth term, this is being bring to the other side, so negative become positive. Okay, why we need to do this arrangement? Because it will make us easier when we want to press the calculator. Okay, we want to arrange this because we want make our life easier. Okay, so we combine all the terms here. So I1 combine I1, so R1 plus RT, R3, and this is the same also, R3, and this is R1. Okay, so the term here, this can be changed to number, but for the sake of this example, I want to make it as a term here, right? So this is equation number 1. Okay, we have 2 more equations we need to do because there are 3 loops. 3 loops mean 3 equations. 4 loops mean 4 equations. The more the loops, the more equation. Okay. Okay, so now we go to the second loop. loop number 2. Also the same, the current is flowing like this. Okay, we set it. We set the direction, okay? The current is flowing like this. So the current here and the current here. And look again, this is the current at R2. Not only I2 but also I3. R3 also same just now, you know, I2 and I1. Okay, now just now we said this R3, the terminal is like this, right? Remember before this? Okay, now the current direction for loop 2 is like this. So the terminal of resistor will be changing also like this. We are following the loop, each loop. Okay, we are following the exact, what we call, position of the loop. Okay, if the loop number 2, the current is like this, so we follow it first. Okay, this is positive and this is positive, this is negative. This one we cannot change lah, because this is the voltage source. Okay, we cannot change anything. So what is the equation here? Look, the current following through here, so this is going through the negative terminal. So what is the voltage? Yes, negative V2. Okay, negative V2, right? And then go to here. This is positive. Okay, you said it already. Don't use the previous one. We said it again. So this is positive. So positive I2 multiplied with R3 plus I2 multiplied with R2. Because this is positive here. Positive, positive, positive. Okay, then look at I1. Because there is a I1 here, right? At R3. So this is already, we said, is a negative. So it goes into the negative terminal. So it becomes, yes, negative I1 multiplied with R3. This is also the same. Negative I3 multiplied with R2. Then we arrange it again, rearrange everything. Okay, we combine, we compule first, we collect first the same term. So I2 here, I1, I3, and then because this is number 1, so we must put it at the first one, I1, I2, and R3. Then this is the fourth term. Then this is the second equation. Okay. All right. Take a deep breath because we are going to the third loop. All right. So this is the third loop. Okay. With third loop, also the same. The current is flowing like this because we said it. Some of you might ask, Doctor, I don't want to flow like this. I want to flow like this. Okay, for loop analysis, this is the number 1 rule in loop analysis. If you set as one loop is like this, so all loops is like this also. Okay. Alright. If you put different directions, semua kena macam ni. Also, so just now I put the direction is like this, so all is like this. Okay, clockwise. Okay. So the current at R1, there is a current flow through also I1. This is R2 also, there is a I2. Okay, what is the equation? Okay, again, for particular loop, the resistor, we put it, set it like this. Follow the current direction. Okay? Okay, the same. Then, what is the equation? So, I3 multiply with, okay, start from here. Okay, multiply with R4. Okay? Positive I3, because to go through the positive terminal, so positive I3 multiply with R2. Also same, I3 multiply with R1. Okay, we get all the I3 terms. And then do the I1 terms, which is this direction. So negative I1 multiply with R2. And this is also the same, negative I2 multiply with R2. Oh, this is R1, sorry. This is R1, this is R2. And is equal to 0. So rearrange everything, and then we get this equation. All right. So we already have 3 equations. No, this is the equation number 1 just now, equation number 2, and lastly equation number 3. Okay, because I cannot reverse anymore. So just now we already have 3 equations. Press your calculator and choose the 4 terms, because there are 1, 2, 3 unknown, and then there is another one at the back. So 4 terms. Okay, press the equation, then choose the 4 terms, and then you insert all the value, and then you get the answer. Okay, let's test your understanding now. So first, this is the given circuit. All right, so the equation, the question is find I1 and I2. Okay, usually they give you the loops already. They already show you the loops to make your life easier. But if the person who makes the question don't like you, maybe they didn't put the loop, and then they just ask like this: find the currents using using loop analysis. Okay, also in loop analysis, some books they use the term mesh analysis. Loop or mesh, the same. Mesh is also like this, loop also like this. All right, maybe you want to do more practice in the book, like the Sadiku book, the reference book. So you want to find the practice, you want to find the question, but there is no loop analysis. Okay, find the word mesh analysis. All right, so first you need to identify the loops. So it's already been given loop number 1 and loop number 2 here. Then you need to apply the KVL to each loop. Okay, what is the equation here and what is the equation here? Remember, in these branches there are 2 currents flowing through. Okay, so you need to give me your equation in the comment section below also. And lastly, you need to press your calculator and give me the currents value. Okay, try, please try by yourself. Okay, if you cannot, just tell me, just comment that cannot, doctor, I don't know, I don't understand, and I cannot do it. All right, try first, try, but if you really cannot, just tell me. Okay, it's okay, Then next is also the same, find I1, I2, and I3. Okay, there is I1, I2, and I3. Looks the similar equation, right? But look carefully, they're asking you another one, I3 here. So they want the value I1 and I3, and I1 and I2 also, as well as I3. So same also, need to use KVL. Find the equation here, very simple. And then solve the equation to obtain I2 and I1 values using calculator only. Just press your calculator. And lastly, how to find I3? You already know I1, I2. Just use the KCL node here at this node. So what is the KCL equation? I1 is equal to I2 plus I3. Then you can get the value of I3. All right. Okay, that's all. That's all for today class is almost 1 hour video. So I hope that you guys understand what I'm saying. Or if you guys have any question, just comment what is your question. Also, maybe you can just ask me through the WhatsApp group, or just during the physical class. If you very shy, just come to me. All right. Thank you, thank you for listening and for your attention. See you in the class. Bye.